ST33 Thyristor control board. Wiring and debugging instructions. How to wire the Thyristor. When wiring the Thyristor, first check the identification diagram on its side panel. This diagram clearly indicates the positions of the 4 terminals, K1, G1, K2, and G2. Corresponding labels are also marked above the actual terminals on the top, K1, G1, K2, G2. Generally, the K1 and G1 terminals correspond to the upper arm of the rectification control. The K2 and G2 terminals correspond to the lower arm. Red wires represent the K lines, white wires represent the G lines. Then, wire accordingly by following the connection diagram in the instruction manual. After wiring, insert the terminal block into the corresponding port on the trigger board. This completes the wiring for one Thyristor. Wire the other 2 Thyristors in the same manner. Pre-power checks. Before applying power, first wire the control board according to the actual requirements. The control board power supply only requires connecting the L1 and L2 wires. Next, connect the LCD screen ribbon cable. Then, connect the pre-wired thyristors to their corresponding ports on the board. Plug in the 3-phase synchronization signal lines. It is important to note, the TU synchronization signal line must be connected to the 3-phase power line connected to the Thyristor's U terminal. The TV synchronization signal line corresponds to the V-phase power line. The TW synchronization signal line corresponds to the W-phase power line. Next, connect the external reference signals sequentially, such as the potentiometer and the start-stop switch. This completes the most basic debugging circuit setup. Close the circuit breaker to apply power. First, set the operating mode to open loop. After setting the mode, apply a reference signal of about 50%. Press the start button. The Thyristor rectifier will now output power. Observe the meter display. It should change linearly, and the voltage should increase. When stopping the output, there will be a soft stop process, and the meter reading will slowly return to 0. For closed-loop control, it is necessary to add a feedback control signal, such as If or VF. These can be added sequentially later based on your specific needs. For example, the one I am holding here is our pre-wired voltage and current feedback signal board. Once the feedback signals are connected, a complete closed-loop control power supply is successfully wired. When using it subsequently, remember to first switch the control mode to constant voltage mode. Press the start button, and the output will now be in constant voltage output mode. Before applying power, it is recommended to connect a 1 kW incandescent bulb as a trial load. Press the start button and observe the change in the bulb's brightness. If the bulb's brightness changes continuously and smoothly according to different set values, then the control board wiring is normal. If loss of control occurs, it is abnormal. Immediately turn off the power and check for wiring errors to prevent damaging components. After the control board is debugged and verified to be working normally, you can connect the actual load for operation.